Okay, everyone, today we are going to do circles. Now, you get ready to exercise your visualization skills, okay? Because we will be moving parts of shaded regions around, we will be drawing extra lines, and there are certain questions that are even more tricky, okay? So, today we'll start off with the easier concepts first. We'll revise some concepts first on how to find the area of a circle, and then we will do some practice questions. Let's take a look. Now, before we start, right, let's talk about a circle. So this is a circle, and this is the center of the circle. If we draw a line from the center of the circle to the circumference of the circle, we call this the radius, R. Okay, radius. Now, how do you find the area of a circle? If you want to find the area of a circle, we use the formula pi r squared. Pi r squared. So the question will tell you what is pi. Sometimes it is 3.14. Sometimes it is 22/7. Really depends on the question. So don't worry about it. Let's just read the question and then you'll know what is pi. And you must identify the radius of a circle. Okay, make sure you know that the radius is from the center of the circle to the circumference of the circle. If I were to draw a semicircle, the radius also starts from the center to the circumference. Even if I draw a quarter circle, the radius is still from the center of the circle to the circumference, okay? Because a quarter circle is part of a big circle, right? So the radius is still going to be from the center of that circle. Okay, you must imagine that it's a complete circle and then you know where's the center. So this is how you find the radius of a circle. You need to identify it correctly. Okay? So we use pi r squared. For example, let's say the radius is 7. Let's say pi is 22/7. So how do you find the area? Pi times 7 squared. What is 7 squared? That means 7 times 7. So you get rid of this and you'll have 22 times 7, which is 154. Okay? So this is how you find the area of a circle. Now, students, we can do the example question. They say that the figure shows a semicircle and a 45-degree sector. So what is a sector? A sector looks like a pizza. So if I take a circle and I cut this out, this is called a sector. Okay? So the 45-degree sector, there you go. And they say that region A and B are equal. And they want you to find, they want you to show that region A is equal to region B. Okay? So, firstly, we can just find the area of a semicircle. Where's the radius though? Everyone look at this semicircle. Where is the center of the circle? This is the center of the circle. So what is the radius? The radius must be 2, right? Okay? Show that the regions A and B are equal. So if I were to find the area of a semicircle, okay, let's say I find a semicircle. The area of a circle is pi r squared. But if you want a semicircle, which is just half of a circle, you have to do half times pi r squared. So what is half times pi r squared? Half times pi times the radius to the power of 2. This is going to give you 4. 4 times half equals to 2. So what do you get in the end? You just get 2 pi. You can just leave your answer in pi first. I know that they told us pi is 3.14, but let's just not multiply by decimals so soon. If we need to multiply by decimals, let's do it later because we want to keep our working simple first. So let's leave it as pi, 2 pi, like that. So this is our radius, this is our area of the semicircle for now. So let's see how we can find the shaded area. Okay, let's look at shaded area A and shaded area B. First, we are going to draw a line. Okay, let's divide this into 2. So now I have a 1/4 of a circle over here. So we call this a quadrant. Alright, this is 1/4 of a circle. What do you have here? A triangle. Okay, so these shapes are easy for us to recognize. We recognize what is a quadrant. We also recognize what is a triangle, right? So if I want to find the area of B, what can I do? I can actually take the semicircle minus the area of the quadrant and minus the area of that triangle. Then I will be able to get the shaded area B. Do you agree? So you already know the area of the semicircle, right? Which we just found. Minus the area of the quarter circle. Students, if you already know the area of the semicircle, 1/4 of the circle is just half of the semicircle, which is just pi. Then you must minus away the triangle. So the triangle is half times the base. What is the base of the triangle? 2. What is the height of the triangle? Also 2. Half times base times height. So now you have 2 pi minus pi minus half times 2 times 2, which is just going to be 2. So the area of B is pi minus 2. How do I know that this height is 2? Okay, because don't forget, this is part of a circle, right? Do you notice that this is part of a circle? So this is the center of the circle. The radius is here. The radius is also here. Students, no matter what direction you draw this line, it is all going to be the same length. Okay? No matter which direction you draw the radius, it's all going to be the same length. As long as the radius is from the center of the circle to the circumference. Okay, so that's how I know that this is 2. And this is also 2. Right? So now we found the area of the shaded region B. Does anyone have any questions so far? Okay, if you have questions, just raise your hand, okay? Now, let's find the shaded region A. So how do we find the shaded region of A? First, we can find the area of the pizza, which is called a sector. So this looks like a pizza, right? Okay, so this pizza here. Okay, let me erase this first. Okay, so this is a pizza. So we find the area of this pizza. And why not we minus away the area of the semicircle. But don't forget, if you minus away the area of the semicircle, that's too much, right? We are not supposed to actually minus the area of the semicircle. Actually, you just want to get rid of this part, right? You just want to get rid of this part, right? But, I mean, obviously, we do not know how to find the area of this part. So what we can do is we can minus the semicircle, but we add back part B. You add this back, because you're not supposed to minus part B anyway. So you add it back. Okay, so we're going to minus the semicircle, but you add part B back. Then you'll get the area of the shaded part A. Okay, so this is a little bit of visualization. Okay, you need to use a little bit of visualization in order to understand this. Okay, so what I'm going to do is work it out. So we know that the pizza is 45 degrees out of the entire circle, 360. Then you must multiply by pi and the radius. Students. Everyone tell me what's the radius of the pizza. Type your answer in the chat, please. What is the radius of that pizza? The sector. Very good, Jacobs. Jacobs knows. En also knows. Very good. Who else? You must imagine it's part of a circle. So students, imagine it is part of a circle. Can you see? Imagine that it is part of a circle. Okay, where is the center of the circle? I know my drawing is not so good. Okay, wait. There you go, something like that. Do you notice that this is the center of the circle? So this is the radius. The radius is 4. Okay? You must imagine that it's part of a bigger circle. You can't say that the radius is 2. Okay, because if you have a sector like that, how do you even get the sector? Can you see that this is how you got the sector? So can you see that this is a radius? Okay? So please be careful, huh? The radius is 4. Okay, so what is 4 squared? 16, right? Never mind. We'll calculate that later. Then you say minus the semicircle plus the area of B. So area of B is actually pi minus 2, which we found just now. Now let's simplify everything. This will give us 1 over 8. This is 16. So 16 divided by 8. 16 divided by 8, you get 2. There you go. Sorry, not here. 2. Okay? 16 divided by 8, you get 2. So now you have 2 times pi, which is 2 pi. 2 pi minus 2 pi. 0, right? 2 pi minus 2 pi 0. Then you are left with pi minus 2. So guess what? The answer is pi minus 2. Have you proven that they are the same? Yes, there you go. They are the same. So that's how we prove that area A is the same as area B, okay? Any questions? Yes, Earn.
Why do you take 45 divided by 360?
Oh no, you simplify it lah. No, I'm saying that this whole thing is 1 over 8.
No, I mean like why do you have to multiply it by pi?
Oh, what's the formula? Tell me what's the formula to find the area of a circle.
Pi r square.
There you go, pi r square. Now I have a circle and I have a sector. I cut out a pizza. This is a pizza, right? This is 45 degrees. Can you see this 45 degrees? So what fraction of the circle is this pizza?
45 over 360.
Yes, correct. 1 over 8, right? 1 over 8, right? Okay, so how to find the area of this pizza? You need to take 1 over 8 times pi r square. Am I right?
Yeah.
That's what I'm doing. 1 over 8 times pi radius squared. Can you see 4 to the power of 2? 1
Yeah.
over 8 times pi r square. So have I answered your question?
Yes.
Good. Thank you for clarifying. Anyone else want to clarify anything? So it's always good to clarify. Okay, then you'll learn. Alright, students, come. Now we will try to do practice number 1. In practice number 1, you have to find a shaded region. However, the shaded region is a little bit weirdly shaped. You don't even know what shape that is, right? So how do you think you're even going to find the area if you don't even know the shape? Then there's no formula that you can use because you don't know what shape that is. So students, why not I give you 30 seconds, right? You just think about it. Can you cut and move around the shaded part so that you can form a shape that you recognize? Type the shape into the chat. What shape can you form if you were to move certain things around and create a new shape? What shape will you form? Type your answer in the chat, please. Alright, very good. Jing Ming and En. You got it, okay? You got it. Look, if I were to draw a line here, can you see that I'm getting a semicircle here? And guess what, students? What if I draw a line here? can you see that I've got a semicircle here and there's a semicircle here as well? What can you do? We can actually cut this shaded semicircle and paste it in here. Then what shape do you get? You will get a quadrant. Okay, students? So, in order to find the area of this shaded region, you need to find 1/4 pi r squared. 1/4 because it's a quadrant. So can you please find the answer and type your answer in the chat? Well done, well done. I can see a lot of correct answers. So we take 1/4 times the pi. What is pi? 3.14 in this question. Times the radius. Okay, so what is the radius? The radius is starting from the center of the circle to the circumference of the circle, right? This is the radius. They already told us that the radius is 6 cm. So we're just going to take 6 to the power of 2. And if you type that into your calculator, you get 28.26 cm squared. Very good, students. You got it. Well done. Any questions? Okay, moving on to question 2. In question 2, they're asking you, find the difference between the area of the shaded region and the colored region. So this is the shaded region. Okay, shaded, that means lines like that. Colored meaning that is full color like this. You color it. They want you to find the difference between the shaded region and the colored region. So what do they mean by shaded? That means those four leaves in the middle. Those are the shaded regions, right? And how do you find the colored regions, students? If you want to find the colored region, what if you take the big circle and you just get rid of the 4 small circles? Will that give you the colored region? Who says yes? Who says yes? Who says no? Raise your hand. Very good. Okay, Ern, you tell me. Why am I not able to just take the big circle minus the 4 small circles?
Because there's overlapping areas.
Correct. Okay, this is 4 circles. 1, 2. Can you already see that the yellow and green are overlapping? 3. Now the red and green are overlapping. And then 4. The yellow and the green and the red are all overlapping. So in order to find the colored region, what should I do? Big circle minus the 4 small circles, and what else should I do?
Add back the color area.
Add
The
back
shape
the
color.
4 leaves, the overlapping region. Thank you. Very good, okay? So students, do you understand that? There's overlapping parts. Make sure you add back the overlapping parts. Any questions? Alright, so let's find the big circle. The big circle is pi r squared. Pi, and what is the radius of the big circle? Oh, they didn't tell you anything. They didn't give you any numbers. It's okay, don't worry. What did they say about the radius? They said that the diameter of a small circle is equal to the radius of the big circle. Now what's the meaning of a diameter? This is a circle. The radius is starting from the center to the circumference. The diameter is actually from one end to the other end, passing through the center. Oh, looks like a pokeball, right? So this is the diameter, the entire length here. That's the diameter, which is twice of the radius actually. Diameter equal to the radius plus the radius. You notice? So they say that the diameter of a small circle equals to the radius of the big circle. Makes sense, right? So let's call this 2r. If you call this 2r, that means the radius of the small circle is just half of that. R, radius. Okay? So the radius of the small circle is just r. The radius of the big circle is 2r. There you go. Pi times the radius squared minus 4 times pi r squared plus the 4 shaded leaves, the shaded leaves. Okay, so let's work it out. 2 to the power of 2 is 4. R to the power of 2, that means r squared, right? So you get 4 pi r squared over here. Then you have minus 4 pi r squared. Now that's 0, right? 0. So what's the answer? The answer is 4 leaves. Guess what? We have just shown that the shaded area equals to the colored area. Therefore, what is the difference between those two areas? 0. There you go. Any questions? Okay, let's try question 3. So in the diagram below, regions X and Y are equal. They are telling you that this equals to this. I know it doesn't look that way. Hey, you know what? Didn't we show that A and B are equal for this question? Yeah. So it's not that unbelievable, right? For area X and area Y to be equal to each other. So they are telling you that region X and Y are equal. And ABC is a right angled triangle. Given that BC is 40, find the length of AB. Okay, great. They are telling you that BC is 40. So the entire length BC here is 40. So the radius should be 20. Am I right? Okay. Given that BC is 40, find the length of AB. So students, why don't you do this? If you really want to find the length of AB, what do you need? You actually need, okay, you already know that this is 40. The question have told you that the length BC is 40 if you know the area of the triangle. If you know the area of the triangle, don't you think that you'll be able to find the length of AB, which is actually the height of the triangle? So students, your mission here is to find the area of this triangle first. Then you can find the height of that triangle. So why don't I give you 2 minutes to try it out? Your time starts now. Alright, so Zoanne, let me ask you this, okay? Zoanne, there must have been a reason why they told us that area X equals to area Y. Don't you think so? Now, Zoanne, if area X equals to area Y, can I safely say that... Okay, hold on. Let me call this part Z. Okay? Can you tell me how to find the area of the triangle? Region X plus region...
Z.
Yes. This will give you the triangle, am I right? But they already told you that X equals to Y, yes? So can I say that the triangle is actually Y plus Z? Haha, yes or no? Because they are equal, yes or no? Yes. So, Zoanne, can you tell me what is Y plus Z? What shape do you get?
Semicircle.
So, do you agree that the area of the triangle equals to the area of the semicircle? Yes, definitely, okay? So, we are going to say that the area of the triangle equals to the area of the semicircle. Zoanne, can you tell me the formula of finding the area of a semicircle?
5 times
Pi, what do you call this? Pi, what? What's the area of a circle? Semicircle is just half of a circle, yes? So, what is the formula to find area of a circle? How do you read this? How do you read this?
Center radius square.
Oh, pi. So this word is pi. This symbol is pi, okay? Pi r squared. Can you say pi r squared?
Pi r square.
Very good. So half times pi r squared. So now you have half. What is pi? In this question, what is pi? 3.14. What is the radius of the circle? I mean the semicircle? The radius of the semicircle. Did they tell you what it is?
40 divided by 20.
40 divided by 2. Very good. 20. And then you must have it to the power of 2. Pi r squared. If we type it into the calculator, we are going to get 628 cm squared. So now you know the area of the triangle. So once you know the area of the triangle, what is the formula to find the area of a triangle?
Half times base times height.
Half times, what is the base of that triangle?
40.
And the height is AB. And we are trying to find AB. So we know that half times base times height is 628 cm squared. So let's simplify this first. Okay, so divide by 2, divide by 2. So 20 AB equals to 628. So what is AB?
628 divided by 20.
Very good. Which will give us 31.4 cm. You got it. Well done. So how? Is it easy now? Thank you, Zoan. Well done. Any questions, students? Alright, great. So here what we did was we actually took this shaded part, and if you think about it, you can actually just move it into the shaded area Y. And you just move it in. It become a semicircle anyway, because they already told you that x equals to y, right? So the area of the triangle is equal to the area of the semicircle. Once you figure that out, that's it. You can solve it. Alright, let's try the next one. Example 2. So remember just now how I actually used the letter Z? I actually used the letter Z here, remember? So what we can do is we can also use the letter Z, because there are certain areas that are not labeled. So if we label them, then it's easier to refer to them. So students, if you look here, right, do you notice that they want you to find the difference between x and y? So what they want you to find is x minus y. That's what they want you to find. Now, would you agree with me if I say that x minus y is equal to x plus z minus y plus z? Right? Like for example, if I ask you what is 20 minus 15? 20 minus 15 equals to 20 plus 2 minus 15 plus 2. Does it work out? Because I'm adding the same thing to both numbers, right? So in the end, they'll just cancel each other out. Right, students? One more thing that I would like to say is, if I were to open up the brackets, x plus z minus y, be very careful. Whenever you see a negative sign outside the bracket, negative and positive, in the end you will get a negative. Whenever you have a negative and a positive, that will give you negative. So let's write minus z. Can you see that the z cancels out? You're still going to get x minus y. Okay? But there's a reason why I purposely want to plus the z. Why do I want to add the z? Because adding the letter z gives me a shape that I can recognize. What shape? Okay, let me ask Jingming. What shape do you recognize from x plus z? What shape do you get? Do I need to highlight it? This is x here, and this is z here. So when you add them together, what shape do you get? What shape do you get?
It was a quadrant of a circle.
A quadrant, yes, a quadrant. So x plus z gives you a quadrant. Minus y plus z. Let's highlight it. What is y plus z? Y plus z looks a little bit weird. Uh-oh, I don't really recognize this shape. So what shape do you call this? Nothing, right? Y plus
It's
z is nothing.
2 times 3 minus the quadrant.
No, no. What we can actually do to find y plus z is you take the rectangle minus the
Quadrant.
yes, rectangle minus the quadrant. Then you'll get y plus z. At least these are shapes that we recognize, rectangle and quadrant. However, do you notice that there's a negative sign here? Right?
Mm.
When you have two negative signs, what do you think you'll get?
Positive.
Positive. Very good, very good. So we'll get a quadrant minus a rectangle plus a quadrant. What is one quadrant plus one quadrant? What shape do you get?
A semicircle.
Yes. So in the end, we just need to take a semicircle minus a rectangle, right? Yes. So can you tell me how to find the formula? What is the formula for finding a semicircle?
Half pi r square.
Very good. Okay. So what is pi here in this question?
3.14.
Okay, half times pi times the radius. Okay, what is the radius of the semicircle?
It's 2.
Okay, let's see. This is 2 cm by 3 cm. So 2 cm and 3 cm. So the radius is 2. You are correct. Okay, half pi r squared minus, what's the area of the rectangle?
6.
Yeah, 2 times 3, 6. So if you type this into your actually, this is 4 times half. 4 times half is 2. You don't even need a calculator for this. What do you get? 4 times half is 2. 2 times 3.14, what do you get?
6.28.
Minus
6.
equals?
0.28.
And you got the answer. Well done. Thank you, Jingming. Good job, okay? Yes, you have a question.
I did it in a different way.
How?
2 times 2 times 3.14 times 1/4. That gives you 3.14. Then take 2 times 3, which is 6. Then 6 minus 3.14 is 2.86. 3.14 minus 2.86 is 0.28.
Wow, that was fast. So instead of using semicircle, you use a quadrant.
Yeah.
So can you explain to me, without using numbers, what shapes did you take? Quadrant minus what do you do? You took a quadrant, then what do you do?
I took the area of the rectangle minus the area of the quadrant.
Okay, which is y plus z. Yes.
Get the remaining area, like y plus z, that part. Then I took then I took 3.14, which is the area of the quadrant, minus y plus z.
Ah, so you didn't find a full semicircle. Okay, that works. Thank you, En. Don't worry, students. There's so many ways to do a question, okay? As long as you visualize it correctly, it's fine. Anyone have any questions? Alright, then let's take a look at practice number 4. In the diagram below, ABC is a right angled triangle. DAC is 60 degrees. So let's label this as 60 degrees. Now, the sector ACD is drawn using AD as the radius. Given that the shaded area is 6 pi, find the length of AB. So what they want is the length of AB. AB is over here. What is this length? Okay, so they already told you that the area of the shaded region is 6 pi. The area of the shaded region is 6 pi. if I wanted to, I can actually make use of this information to find what is the radius of this sector. What is the radius of this sector? Now, can I ask Vedant? Hi, Vedant. Vedant,
Hi.
can you tell me what fraction of the entire circle is this shaded pizza? You already have the angle, right?
1/6.
Very good. Because they told you it's 60 degrees, so 60 degrees out of 360 is 1/6. So we know that the pizza is 1/6 of the entire circle. So 1/6 times pi r square. That is actually the area of the pizza. And they told you that the area of the pizza is 6 pi. Well, immediately we can get rid of the pi. So we notice that, okay, let's simplify this, 1/6. So everyone, we can see that 1/6 r square equal to 6. So what is r square, Vedant? Well, how do you get rid of 1/6? In order to get rid of
Bring
one,
it to the
you,
bring,
if you want to get rid of it, you must multiply by how many? To make it into a 1.
6.
Yes, multiply by 6 on both sides. So if you multiply 6 on both sides, this
36.
very good. This will become 1. Okay, and then this will become 36. So what is r?
6.
There you go. So now we know that this AC is 6. But does it even help you to find the length of AB?
No.
I don't know, we're stuck. Can we use Pythagoras theorem?
Yes.
But if you want to use Pythagoras theorem, you need to know this length as well. Do we know this length? We're stuck. Give up.
No.
Cannot be solved.
Wait, I think so, I know.
Why? What should you do?
So AC is same as AD, like, because
AC is the same length as AD. Oh yeah, of course, this is 6. Yes, radius, yes, correct. So, even you know this is 6, you can't find this, or you don't know what this is, right? Anyone have any ideas, or are we really stuck? 6, 8, 10 cannot work. I mean, you're just guessing what, 6, 8, 10. Nobody said that that's 8. Pythagoras will not work, because they didn't tell you what is this length. Right? Okay. Anyone have any ideas? Or are we really seriously stuck? Okay, Vedant, are you ready for some magic?
yes.
It's not really magic, okay, but I'm just going to duplicate this triangle. Now, Vedant, if I were to duplicate this triangle, right, it's like a mirror image. Can you tell me the angle here?
60 degrees.
Do you start to notice something?
Yes.
What? What is this angle here?
The 60.
Yes. How do you know that this is 60 also?
Because all this angles of a triangle, it adds up to 180.
Correct. The sum of angles in a triangle is 180. So if this is 60, this is 60, this is also 60. And what kind of triangle do you have?
Equilateral
Yes,
triangle.
you have an equilateral triangle. That means all the sides are the same length and all the angles are the same as well. So
That means it's 12.
very good. 6 plus 6 here. So this gives you 12. That means all the sides of this triangle is the same. That means this is also 12. Therefore, AB equals to 12 cm. Well done. We got it. Thank you, Vedant. So, students, tricky, right? Okay, but you just need to visualize. Huh? When you duplicate it, you get an equilateral triangle. Okay? Alright, let's move on to the next one. Question 5. The figure below shows two quadrants and a rectangle. Find the area of the shaded region. So where is the quadrant? We have one quadrant here, which is a small one. And you have a big quadrant, really big one here. There you go, really big one. So they want you to find the area of the shaded region. So what if, okay, let's say I would like to find the area of the shaded region. What if I were to take the small quadrant plus the area of the big quadrant? Will that give me the shaded area? I don't think so. Okay, that means I'm taking the small quadrant plus the area of the big quadrant. That will not give me the shaded area. Okay, because if you look at the diagram, this white part is not supposed to be shaded, and this tiny little part here is also not supposed to be shaded. But so what can I do in order to find the shaded region? You take the small quadrant plus the big quadrant. What else can you minus? Because you know that these parts are not supposed to be shaded, right? So what if I minus them away? So in order to find the shaded region, what should you do? Okay, let's write it down. Shaded region equals to the small quadrant plus the big quadrant minus the part that is not supposed to be shaded, which is the rectangle. Okay? You think about it, why must you minus the rectangle? Because when you add these two together, okay, let's say you add this quadrant plus the big quadrant, do you notice that there's an overlapping part? Do you notice that this part is already overlapping? I've already added this part twice, so I need to get rid of it anyway. And I also need to get rid of this part and get rid of this tiny little part here. Don't you see that this tiny little part plus this part plus this part gives you a rectangle? That's why you need to get rid of it. Okay, you already have an overlap of 2 times here. You're supposed to get rid of this part and get rid of this part because they are not shaded. That's why we are getting rid of a rectangle. Okay, so that's how we do it. We take the shaded region equals to small quadrant plus big quadrant minus the rectangle. Now be very careful of the radius. The radius of the small quadrant is 2 cm. The radius of the big quadrant is 5 cm. So when you do your formula 1/4 pi r squared, just make sure you use the correct radius for the correct things. Okay? I will give you 2 minutes to calculate this. Type your answer in the chat. Your time starts now. Alright, students, you know something? If you don't have a calculator, it's fine. In fact, you know something? It's okay to leave your answer in terms of pi. Okay? It's okay to leave your answer in terms of pi. So, what we can do is this. Small quadrant plus big quadrant. So we have 1/4 pi r squared plus 1/4 pi r squared, which is the bigger radius, minus the rectangle, which is simply 2 times 5. Now, if you want to leave your answer in pi, it's fine. 2 to the power of 2 is 4. So 4 divided by 1/4 is just 1. So you have 1 pi here. This is 25. 25 divided by 4 is 25 over 4 pi minus 10. So what do you get? 1, okay, this is 1, 1, plus 25 over 4 is 29 over 4 pi minus 10. If you leave your answer like that, and then you just write cm square, it's fine. No problem. But if you have a calculator, type it in, because pi is 3.14, right? So 29 over 4 times 3.14 minus 10, you just type into your calculator, and there you go. Okay, students? Yes, an question.
Is it like, can we put as 765 per side?
Well, which one? What? 7 what?
12.765.
Can. Okay, in fact, when you type in the calculator, okay, usually in the exams, okay, if you are in a math competition, usually they'll give you multiple choice. Then you just select the best answer. And if it is an open-ended free response question, then they will tell you to leave your answer in one decimal place, or sometimes they will tell you to leave your answer in 3 significant figures, or sometimes they want it in 2 decimal places, which is quite rare, okay? So if it is 1 decimal place, you round it up. Okay, when you round it up, you get 12.8. There you go. Okay? Alright. So let's try the next question. Question 6. The figure below shows a right angled triangle ABC and a semicircle. So you have a right angled triangle, you have a semicircle, and they told you that AB equals to 10 cm, BC equals to 5 cm. So this entire thing here is 10, this entire thing here is 5. So find the area of the shaded region. Okay, students, let's label the parts, because there's so many different parts here. Let's label this A, B, and C. A, B, and C. Okay? This is going to be 10. This is going to be 5. Now, I also would like to label the 2 unshaded parts, so that it's easy for me to refer to them. So why not I call this unshaded part number 1 and unshaded part number 2. Okay, so just to differentiate it easily with the letter U, unshaded. So we have 3 shaded parts, A, B, C, and 2 unshaded parts. So firstly, right, we are going to make use of all these alphabets to create shapes that we recognize. Okay, what shape, what alphabet gives us the big semicircle? Well, if you take A plus B plus the unshaded part number 1, we will get the semicircle, the big one. What about the small semicircle? If you take part B plus part C plus the unshaded part number 2, that gives us the small semicircle. And what about that triangle there? Okay, so the triangle is made up of the unshaded region 1 plus the unshaded region 2 plus part B as well. So that is the triangle. Now, students, they want you to find the area of the shaded region. Shaded region, A plus B plus C. That's what they want. Let's try to add up the big and the small semicircles. So big semicircle plus small semicircle, what do you get? You are going to get the big semicircle A plus B plus the unshaded part 1, and the small semicircle, which is B plus C plus the unshaded part 2. And then you notice something. If I were to rearrange the alphabets, what do I get? Aha! What is this? Isn't this the same as this? So what shape is this? We have ourselves a triangle right here. So if I were to take the big semicircle plus the small semicircle, I will be getting the shaded parts. Okay, this is the shaded region that they want. plus the triangle. So if you really want to find the shaded region, how are you going to do it? You figure that out. I give you 2 minutes. Your time starts now. Type your answer in the chat. Okay, Max, come, let's take a look here. If I take the big circle plus the big semicircle plus the small semicircle, it is equivalent to the shaded area plus the triangle. Do you agree?
Yes.
So how should I find the shaded area? So in order to get the shaded area, I need to take the big what
Semicircle
plus the small semicircle, and what else?
with the shaded area.
Huh?
Oh no, with the triangle.
So you're gonna add the triangle as well?
Minus the triangle.
Very good. Minus the triangle. Excellent. So how do you find the area of the big semicircle? What's the formula? Tell me the formula first.
Half pi r squared.
Very good. Okay, so half pi r squared. Now what is the radius of this big semicircle?
5 centimeters.
Yes, 5 centimeters. And what is the radius of the big small semicircle?
2.5 centimeters.
Yes, 2.5 centimeters. Okay, so big semicircle, so half times pi, what is pi? 3.14. Okay, you know what, half times pi times 5 squared plus half times pi times 2.5 squared. Now, do you notice that half pi and half pi keeps repeating?
Yes.
What can I do? I can
Cancel them out.
you don't really cancel them out. What you do is you take it out, put it outside a bracket, and whatever is left behind remains in the bracket. So you have half pi 5 square plus 2.5 square. There you go. Okay, because the half pi will then be multiplied by 5 squared and also be multiplied by 2.5 squared, which is actually what we wanted in the first place. You get it?
Yeah.
Alright, then you can minus half times the base times the height. What is base and height of the triangle?
Base is 10 centimeters and height is 5 centimeters.
Okay, let's do that. Half times the base times the height. And then, if we were to type it into the calculator, we are going to get 5 squared, which is 25, and 2.5 squared is going to give us 6.25. So, half times pi times 31.25 minus 25. There we go. So we will end up with a lot of decimals, but it's okay. Let's work in terms of one decimal place, okay? 49.1. Yeah, actually it's 49.06 minus 25. So when we minus the 25, we get 24.06, which is actually, if we simplify it, we'll just 24.1 cm squared. Well done! You got it, Max. So was this easy or difficult?
It was okay.
It was okay. Alright, well done. Thank you, Max. So students, can you see that we labeled all the different parts? And when we label the different parts, we can make use of the alphabets to figure out what we must do. Any questions? Okay, very good, huh? Jing Ming, you got it. Well done. En got it as well. Good job. Okay, so let's try the next one. Oh, look at example 3. So, in example 3, they say that A, B, C, D, and D, E, B, F are parallelograms. Oh yeah, sorry. Everyone, can you just change this to E? It's actually EAB. There's no O here. There's no O here. Okay, they say that EAB is 30. Yeah, there's no O. It's a typo error. Okay. So in the figure below, you have parallelograms. You have AD equals to 8 cm, AB is 10 cm. Okay, AB is 10 cm, AD is 8 cm. Okay, the radius. Okay, find the area of the shaded region. Okay, so we're just trying to find the area of the shaded region. Now, let's take a look at the area of AEB and the area of CFD. So where is AEB? AEB is this pizza. And where is CFD? CFD is this pizza here. Guess what? They are the same. So we say that they are equal. Okay? Now, how do we find the area? We know that it's 30 degrees, right? So we say it's 30 degrees out of 360 degrees times pi r squared, because we know the radius of this pizza is 10. How do I know that the radius is 10? Imagine that it is part of a bigger circle. Do you notice that this is the center of the circle and 10 cm is the radius? Okay, so ask yourself, is it part of a circle? Yes, it's part of a big circle. The radius is always from the center of the circle to the circumference of the circle. That's why the radius is 10 here. Now, if you work this out, we'll get 25 over 3 pi. So this is the area of the pizza. Now let's find the area of the other pizza. Where's the other pizza? I think we need to find the area of the smaller pizzas. Okay, ADM and CBN. These two pizzas, they are the same. So let's find the area of these two pizzas. Area ABM and area CBN. They have the same area, which is 30 degrees out of 360 times pi times the radius. What is the radius? Now it is shorter. It is 8. Can you see that it's part of a smaller circle? So the radius is 8 pi r squared. And if you type this into your, no, you don't even need a calculator for this. If you work this out, this is 1 over 6, right? Sorry, this is 1 over 12. 1 over 12 times 64. If we simplify it, you get 16 over 3 pi cm squared. Any questions so far? Okay, and what is the area of ABCD? ABCD is a parallelogram. When you want to find the area of a parallelogram, you take the base of the parallelogram, multiply by the height of the parallelogram. So what is the height of this parallelogram? The height of the parallelogram is right here. And it is given to us that it is 4 cm. So let's write down 4 cm here. So that's the height of this parallelogram. So I'm going to write down the area of the parallelogram is the base times the height. Now, if you want to find the shaded area, what must you do? We are going to look at the diagram. We're going to look at the area BEDF. Can you see the area BEDF, which is this weird shape right here? This weird shape. If you have this weird shape, you minus the unshaded part in the middle, get rid of this red part, which is also another weird shape. Then you'll be able to find the shaded region. Am I right? So let's write it down first. You want to find the shaded region, you need BEDF minus BNDM. There we go. How do you find BEDF? Look at BEDF. It's a big, weird shape. And how would you find the area of the big weird shape? Okay, if I were to take a pizza, right, and I were to multiply it by 2. Okay, let's say I add another pizza. Okay, I add these two together. If I were to add these two together and then I minus the parallelogram. Okay, minus this parallelogram. Right? That will give me the area of BEDF. Okay? Can you see it? You add the two pizzas, you minus the parallelogram, you get the area of BEDF. What about the smaller part, which is CNDM, this smaller part? How do you find that? You take the parallelogram minus this quadrant and this, not quadrant, it's not a quadrant, minus this pizza and minus this pizza. Then you will be able to get the thing in the middle. Okay, so let's write it down. 2 pizzas minus the parallelogram minus, okay, so this is BEDF minus BNDM. How do you find BNDM? You take the parallelogram minus 2 of the smaller pizzas. Okay, now you already know that AEB, which is the bigger pizza, equals to 25 over 3. So if you multiply it by 2, you get 50 over 3. Then you minus away ABCD. And then you need to minus another ABCD here. However, minus and minus gives you a positive. So we need to add 2 times ADM. What is ADM? We just found it. It's right here. This is ADM. Okay? Sorry, ABM. I should write ABM, not ADM. Okay, so you minus 2 times... Oh, no. It's D. Look at the diagram. ADM. Yes, it's ADM. Why am I writing? Okay, I should write D. Okay, ADM here. ADM equals to CBN. Okay? Yeah. So we have 2 times ADM. So 16 over 3 times 2 is 32 over 3 pi. So what is 50 plus 32? 82 over 3 pi minus 40 minus 40. You get minus 80. If you want to leave your answer like that, you can. But if you have a calculator... Wait, is it 3.14? Yes, pi equals to 3.14. So for this question, pi equals to 3.14. If you have a calculator, you type it into your calculator, you'll get the answer 5.8 cm squared. There you go. Okay, so this is how you visualize it. When you have weird shapes, you need to add them together and minus certain parts. Okay, so the key here is to visualize this. If you can visualize this, no problem. You'll be able to solve the question. Okay, now let's try the next one. Practice number 7. In the figure below, O is the center of the circle. CD is perpendicular to AB. AB is equal to 10 cm. And there's an arc, AEB. So this is an arc, AEB here. Find the area of the shaded region. Now, students, in order to do this, let's draw another line. Okay, do you notice that there's a right angle here? So students, can everyone type in the chat, what shape do you get over here, students? Tell me, what shape is this? Yes, very good. I can see you typing in the chat. It is a quadrant. Okay, this yellow part is a quadrant, which is 1/4 of a circle. Now, everyone, we know that AB is 10 cm. Okay, AB is 10 cm. So, if AB is 10 cm, that means the radius of this circle must be 5. Okay, and when you talk about the radius, okay, if you have a radius which is 5, in any direction, it is still going to be 5. So even if I draw a line pointing downwards, this is still 5. Even if I draw a line here, this is also 5. So anyway, the main thing is, this line here, OC, the line OC, is also going to be 5. Right? So can everyone type your answer in the chat? Can you tell me what's the area of the triangle ABC, please? Type your answer in the chat. Area of the triangle ABC. Half times base times height. You can quickly do it mentally. Very good. Yes. Very fast. Good. I can see the correct answer. The area of the triangle ABC. Half times the base times the height, which is 25. Easy. It's easy. Now, if you look at the area of the triangle ABC, there's also another way to find the area of the triangle ABC. Instead of taking the base to be 10 over here and the height to be 5, instead of doing that, which we have just done actually, this is what we have just done, right? There's another way. We can say that this is the base and this is the height, because as long as the base and the height is 90 degrees to each other, you can find the area of the triangle, right? So we can also say that the area of the triangle ABC equals to half times the base times the height, right? So you know something? AC and AB, AC and CB, aren't they the same length? So if they are the same length, you know what we can do? We can say that this equals to AC times AC, because they're the same. They're the same anyway. CB is the same as AC. So now you have AC times AC, that means it's AC squared, right? So what can you say? We can say that half AC squared equal to the area of the triangle, which is 25. So if you multiply by 2 on both sides, get rid of this half, you'll end up with AC squared equals to 50. That means AC, never mind. Let's just leave it here. Let's just leave it here. AC squared equals to 50. Any questions so far? Anyone have any questions? Okay, now it's time for visualization, okay? How do you find the shaded region? If you want to find the shaded region, we have to take the semicircle plus the triangle. Then we need to get rid of the quadrant. Get rid of this quadrant. Then you will be able to get the shaded region. Okay, so we have a semicircle plus the triangle. Then we get rid of this quadrant. We end up with the shaded region. Okay, now let's do that. Semicircle plus triangle minus that quadrant. So we need to have the semicircle. We know that this is 5 cm, right? So the radius of the semicircle is 5. And we have also found the area of the triangle already. Now you just need to find the area of the quadrant. How do you find the area of the quadrant? The radius of the quadrant is AC, right? Now, obviously you don't know what is AC, but you do know that AC squared equals to 50. That is already going to help you to find the area of the quadrant. Okay, so students, can I give you 2 minutes to calculate what is the area of the shaded region? Type your answer in the chat. Your time starts now. Okay, the good news is you don't need a calculator for this, okay? What is the... We already know that the radius of the semicircle is 5. So if you want to find the area of the semicircle, we just take half times pi times the radius squared, half pi r squared, plus the area of the triangle, which we have already found, minus the area of the quadrant. The quadrant is 1/4 of a circle. 1/4 of a circle. What is the radius of the circle? The radius of the quadrant. Radius of the quadrant is AC. AC. So I'm going to write down AC squared. Guess what? You already know what is AC squared. It is 50. Right here, okay? So you have 5 times 5 is 25. 25 over 2 pi plus 25 minus, this is 50. 50 over 4 pi. Do you know something? 50 over 4 equals to 25 over 2, and they cancel each other out. Therefore, you will get 25 cm square. Well done, Jacobs. You got the answer. Students, can you see? Don't complicate things. If you work in terms of pi, suddenly it cancels each other out. You don't even need to calculate pi. You don't even need 3.14 for this. Okay? Any questions? Alright. Let's try question 8. 2 concentric circles are shown in the diagram below. Line AB is tangent to the smaller circle. Okay, students, you know what I'm going to do? This is the center of the circle. So I'm going to draw a radius here. This is the radius of the small circle. And I'm going to draw a radius here from the center to the circumference. This is the radius of the big circle. So I'll call this a small r, and I'll call this a big R, because big R is the radius of a big circle. What else did they say? They said that the line AB is 12 cm. So if the line AB is 12 cm, then what is the length here? 6. It is half of 12, right? Now everyone, before we move on, let me revise. What is the Pythagoras theorem? Pythagoras states that when you have a right angle, okay, let me draw a proper right angled triangle. When you have a right angled triangle, the two shorter sides are A and B, the longest side is C. Actually, what is the relationship between them? The shorter sides added together and squared will give you the longest side squared. So A squared plus B squared equals to C squared. For example, this is 3, this is 4, this is 5. Do you notice something? Do you notice that 3 squared plus 4 squared equals to 5 squared? What is 3 squared? 3 times 3, 9. What is 4 squared? 4 times 4, 16. Equals to 5 times 5, 25. It works, right? So this is Pythagoras theorem. Why am I talking about Pythagoras theorem? Because I have a right angled triangle in here. Can you see that? So what's the relationship between my R and a R and 6? By Pythagoras theorem, we say that the small r squared plus the 6 squared equals to the longest side squared. Now if I move this over to the other side, it's going to become negative. So I have r squared minus r squared equals to 36. There you go. Leave it like that. Now let's work on our shaded region. They want you to find the shaded region, so what must you do? In order to find the shaded region, we need to take the big circle minus the small circle. How do you find the big circle? Pi r, pi big R squared minus pi small r squared. Do you notice that pi keeps repeating itself? What I'm gonna do is I'm gonna remove it, put it outside the bracket, and what do you have left? You have r squared minus r squared remaining in the brackets. So what is r squared minus r squared? 36. The answer is 36 pi cm squared. If you want to leave your answer like that, please go ahead. Okay? Or if you have a calculator, actually you don't need to. Just leave your answer like that. They didn't even tell you that pi is 3.14. Just leave your answer like that. Anyone have any questions? See how helpful Pythagoras is sometimes? Okay? Alright, let's try the next. Oh, that's it. That's the last question. So what I'm going to do is this. We are going to do our bonus questions. Alright, everyone. Let's take a look at our bonus question, okay? The very first bonus question shows a 12-sided polygon. So this entire figure here is actually a polygon with 12 sides. And they're telling you that the side length is 1 cm. Inside, okay, so this is 1 cm. Okay, each of this is just 1 cm. Find the area of the shaded region. Interesting. Students, this shape is obviously something that we have no formula to find the area of. So we have to try to rearrange certain things so that we can get things that we recognize. So let's take a look. I'm going to draw some lines, okay? Here I've drawn a 6-sided figure, hexagon, a hexagon. I'm going to divide the hexagon into triangles. What do you notice? Okay, students, look. Do you notice that there's a triangle here and there's a triangle here? So if you take this shaded triangle and you move it to fill up the empty space, we can get shapes that you recognize. Okay, what shape are you getting? Let me show you. Do you notice that this is a square? Now you have already gotten a square because you cover up the empty space. Here you go, you have one square here. You end up with another square here as well. And if you keep on doing it, you end up with another square here, another square here, another square here, another square here, and they already told you that each side is 1 cm. So you have 6 squares. You have 6 of these squares. Therefore, the shaded region is 6. Amazing. From something so complicated, it becomes 6 squares, right? So this is the power of visualization. Okay, let's practice the power of visualization below. Question 2, bonus question 2. The figure below is made up of 4 circles overlapping each other, okay? And they say that the radius is 1 cm, but they would like you to find the perimeter of the shaded region. Students, please take note. They would like you to find the perimeter of the shaded region, not the area, the perimeter. Whenever you hear the word perimeter, you always think of outline. You outline the diagram. So outline is only on the outside. It's never in the inside. That's what you're trying to find. You're basically trying to find, I think, yeah, you're trying to find this shape, right? Flower. Yeah, I think there's a very famous jewelry that is in this shape. I forgot the name of it. Never mind. Okay. So students, we just need to find the outline, right? So before we do that, can I just revise with you how to find the circumference of a circle? You know the area is pi r squared. But if you want to find circumference, it's 2 pi r. So that means you take 2 times pi times the radius. That's it. So, firstly, let us determine what is the radius. Did they tell us anything? Oh, radius is 1 cm. Okay, they told us the radius, no problem. Next, we must visualize. Okay, let me erase this first. 2 pi r. Okay, let me write down 2 pi r. That is how you find the circumference of a circle. Now, let's visualize something, students. This is the center of the circle, okay? If I were to draw a line here, the radius, which is 1 cm, and I were to draw another line here, what do you get? Okay, notice what I'm doing. Taking a circle, drawing a line here, and drawing a line here. I'm getting this pizza, which is quite a big piece of pizza, right? It's actually 1/3 of, do you notice it's actually 1/3, right? So what I'm getting is this pizza over here. So why am I trying to get this pizza? Because I would like to know what is the length of the outside circumference here. I would like to know the length of this red curve. The red curve, which is an arc. We call it an arc. The red arc. So, since we know that this is 1/3 of a circle, we will find the length of the red arc by, okay, so we say the one of the arcs, 1/3 times 2 pi r. So you have 1/3 times 2 times pi times the radius is just 1. So what do you get? You get 2/3 pi cm. Now this is one arc. What do you notice about the outline of the entire shape? We already found what is one arc, right? So let me ask Zach. Hi, Zach.
Hi.
Okay, Zach, do you agree that all the circles, they are actually overlapping each other and touching the center of each other? What do I mean is that,
Yes.
yes, this is the center, this is the center of a circle, this is the center of a circle, this is the center of a circle. So if I have an arc over here, and let's call this the blue part, and let's call this the yellow part, do you agree that the blue part of the arc equals to the yellow part of the arc?
Yes.
Yes, because we are cutting the arc into half. Okay, because they intersect each other in the middle. So if I have an entire arc like that, if I cut it into half, then it will give me this. So can you tell me how many of these half arcs do I have in the entire shape? How many?
8.
Yes, 8. We have 8 of the half arcs. Now 8 of the half arcs equals to how many complete arcs?
4.
Yes. Then we say it's 4 arcs. So what's the answer in terms of fraction and in terms of pi?
Yeah.
Multiply for me. What do you get? 2/3 times 4 is what? It shouldn't take that long. 2/3 times 4 is? Zach, you don't know what 2/3 times?
I forgot how to multiply fractions.
What?
Yeah.
Jesus. Okay, when you multiply fraction. Okay, one. Okay, let's do an example. Okay, 2. I can't believe I'm teaching this. Okay, 5/7. You just need to take the top.
Yes. Multiply bottom, multiply top.
Ah, yes, very good. Multiply the top by the top, the bottom by the bottom. But in this case, is there a top? Number 4, is there a top and is there a bottom for number 4?
No.
Yes, there is.
Oh.
Do you
it's
believe 4 over what?
4 over 4.
4 over 4. What is 4 divided by 4?
1.
1. No, it's not 4 over 4. Do you know? Okay, tell me, is 4 a whole number or is 4 a fraction?
4 is a whole number.
Can I say that 4 is a fraction?
Yes.
Yes or no?
Yes.
Why?
Because 4 can be converted into
4 over
1.
yes. So when you take the top times the top, bottom times the bottom, what do you get?
8 out of 3.
Yes, very good. So remember, there's always a denominator for whole number. So whole number, if you want to write it as a fraction, the denominator is always 1. Okay? Alright, so the answer is 8 out of 3 pi cm. Thank you, Zach. Well done. Any questions about this? Alright, so everyone, good job today. Not only have we completed the worksheet, we have also done a bonus question. Okay, so students, what are the main concepts, main formulas that we learn? Pi r square, how to find the area of a circle, and another one is 2 pi r, which is the circumference of the circle. Now, what are the techniques that we have used? We actually drew lines, we cut the shapes, we wrote alphabets to label different parts. Then when you add the alphabets together, you make things that you recognize. So it's all about recognizing stuff. Okay, well, even when you take some shaded parts and you move them here and there, you rearrange them, you are actually trying to get things that you recognize. Because when you recognize it, then you know the formula to find the area. If you see a shape you don't recognize, then obviously you can't find the area because there's no formula for that. So it's all about cutting and pasting, moving things around, drawing lines, visualizing. How do you improve your visualization skills? Well. There's no secret method to do that, but the only way to do that is through exposure. So the more different types of questions that I expose you to, the more you will learn how to visualize in different ways. So what I'd like you to do is this. Please wait 2 days and then print out the worksheet again, look at all the diagrams and see whether you know how to visualize them. Okay? If you don't know, never mind, look at the solutions. If you still don't understand, watch the lesson recording. You will improve your visualization skills. Alright, students? Alright, good job today, students. I'll see you next week. Bye, everyone. Bye, Jingming, Zach, Zoan, Jacobs, Vadan, Max. Bye, Bye, Albert. Bye.